Hello and welcome to the third evening where we talk a bit about Unreal once again. This will be the last evening for now where we'll be talking about Unreal, and we'll be closing up a bit with the Basics 101. If you've never used Unreal so far, where to start, where to click, and how to get going. Last time, you can see it down there, down there, you can already see our revolving door revolving. It's just not supposed to be a revolving door, so we're gonna be fixing this today. Last week, we built the door and we started looking at blueprints, what blueprints are, how they work, and how you give it a look, how the mesh actually comes into the blueprint, so the door is actually in the level as a door. And we started a bit coding in blueprints with, so the door actually does something, our actor actually does something. We're going to be continuing on this today and see that the door that currently just goes round and round and round and round and round and doesn't stop, that it eventually stops. And then we'll take a look at actor components. This is also something we've talked about in quite some detail in the last set of sessions where we were doing C++. We talked about what are components, the different components, what's an actor component, why is an actor component. So if you want to brush up on more detail, just check out the previous sessions. Today we're going to be looking a brief look at what's an actor component, how does it work, how do we use it, and why should we want to use it? So without any further ado, let's get going. Yes, and here we are, right into the big scene with where you can see everything and where everything's happening. So let's immediately dive back into what we're doing and how to continue from there. You can see our door here, our lovely door that it revolves. It rotates, and see, we haven't even properly started yet, and my throat also cries for lubrication. Which of course it should get, so we can keep talking to each other. So I'm going to be stopping this because this was actually running in play mode. This is the thing we built. We just made, just to summarize a bit. Oh, is that like a horrible frame rate for you guys? Is that like the capturing doesn't really work? Okay, let's hope my streaming PC bears with me at least till we're done with this. I mean, we're not doing any high frame rate stuff today. So yeah, the camera looks okay, just the capturing of this is a bit messed up. I'm not exactly sure why. Well, let's see. Again, we're not doing high frame rate stuff today, so instead of just rebooting the whole streaming PC and again having a break for like 5 to 10 minutes till everything's running, we just live with this for now and just hope the streaming PC doesn't lock up again like last week. Yeah, if someone, I don't know, has the need to donate any streaming PC to me, feel free, contact me. I'll give you my address and you can drop by and leave the PC. Anyways, so these are the buildings, just to see what we did in the past. These buildings, we made static meshes out of them. If you want to see how, just check back the previous sessions. We used the geometry here, the BSP brushes, the volume brushes. We used them to block out a rough room with a hole for a door and a window. We created a proper static mesh out of them, so we could also then reuse the mesh and stack on top of each other. So we get this kind of skyscraper thing. Then we did the same thing with something that looks like a door. We built ourselves with the very same techniques a neat and nice door. Thomas, hi there. A wonderful. Is it already evening? Yeah, it's already evening. Let's call this an evening. Hi there. Greetings go out. So yeah, we build a static mesh there, same techniques, and we dropped the static mesh into an actor. We looked at what an actor is, and again, if you need more detail on this, check out the previous sessions where we did C++, because we talked quite a bit about this. And then we started doing some blueprinting, some blueprint code. I don't have a problem with calling what you do in blueprint coding. Some people say, nah, you can't, can't do that, isn't whatever. But yeah, you basically, well, that's a long discussion for a long evening with a lot of not so soft beverages, maybe. So we did some blueprint coding for now. We just called it that because I'm totally fine with calling it that to make the door move. So if I hit the play button and I go into play mode, we can see the door starts swinging open, but it just doesn't stop. It just keeps swinging until it eventually clips through the door, through the wall, and goes round and round and round. And this is something we might want to fix. So the first thing I need is to find our blueprint. I think I put it somewhere here in the content folder. It might be this one, but then again, you can just click your object in your scene. Again, we are in edit mode now, where I left play mode again. So you can just click your actor, your object here, and then you have it selected in the world outliner, and you have your edit BP door actor here. You don't have those for the brushes or static mesh or anything because you can't really edit them in that way. You can edit the brushes, but it's differently. You just modify them. We've looked at this, how you can modify the geometry of the buttons, of the volumes and everything. So, but for the blueprint, we actually got a neat little edit link. So we just click that. And there we go. We're inside our blueprint for this actor we've done last time. Also, I think there is a way to actually highlight the asset in the asset browser, in the content browser. Here, browse to asset, and there, let's say I'm in a different folder, and I say browse to asset, it jumps into the folder where this asset is placed, and already immediately selects it, highlights it, so I know, okay, this is my blueprint. So there, I can open it. What we did here in this neat little blueprint code, and this is actually code. So this is why I was saying that whatever you do in blueprints, there's no problem calling this coding and calling your blueprint stuff code, because that's basically what you do. This is the very same thing you do when you're writing code the classic way, like you type it into your editor, you save it, you compile it, and then you run it. It's the very same thing, and this ping up there gets annoying, so let me just tell it to stop. See? There it stopped. So yeah, this is actual code. It's just not written in lines. It's symbolized with neat little notes and lines, and it's colorful. It's just a joy to look at, and well-made blueprints that are structured and organized and not just a total mess can actually be a pretty thing. Yeah, code can be pretty. Also, one thing, just let me show this to you, because this line kind of invites me. If you try to keep your blueprints neat and tidy, like I like to, and I expect from everyone who's making blueprints that I ever have to see, you can see this line looks a bit, it's okay-ish, and if I move it to here, it doesn't go through this node, through this other box, but then these lines don't really neatly match up, so I'd like to move this, I don't know, like so or so. So these lines match up a bit better, and then this one goes kind of through the node. It goes behind the node, and it's a bit semi-transparent, so you can actually see there's still a line hidden there. And what you can do is you can just double-click anywhere on such a line. You can just double-click anywhere you want, and that gives you a so-called redirection node, which is just a little pip, a little connection thingy like this one that you can move around, and all it does is connect two lines. How can I move it around? No, this is how I can move it around. And if you want to have another one, just double click and you have another one. And all this does is connecting two lines, one inbound, one outbound, nothing in between. There's nothing that is. It's just a neat way to actually route your lines, your wires, how you actually want them, to clean them up or to resolve, like if they're crossing too much or anything. And of course you can just delete them, which deletes both lines that go in and out, but that's not a problem because then you can just reconnect. This now, for those of you who are a bit OCD plagued, you can see that this is not perfectly straight. This line goes a bit upwards, and if I say, yeah, good, okay, no problem, I can just move this thing up, well, then it goes a bit downwards. Maybe you actually want it to be perfectly straight, and Unreal also has you covered there. You just select whichever nodes. You can do this with as many nodes as you want at once. All the nodes that you want to straighten up. Right now it's only this and that, and then you hit the right mouse button, and then there is a alignment menu, and that has a sub option, straighten connections. And like magic, it's a perfectly straight line. Now we can select both at once and can just move them around, so our lines look neat and tidy and everything is wonderful. And you might actually win your next art prize if you do this a bit more. So that's just in the side note. If you actually do want, or someone forces you to keep your blueprints neat and tidy and clean, this is how you can do it. There's also another way to add these redirection nodes. If you just hit anywhere on where there's nothing, just on a free area, hit the right mouse button, and in this menu that we know already, let's get it a bit more up. In this menu that we know already, where we got all these things from, where we called functions from, if you scroll all down to the bottom, there should be a add reroute node option. And if you hit that one, it's exactly what you get. You get one of these little reroute nodes, and then you can just plug anything. You can just you can plug this in there, and then you can plug this in there, and place them and connect your stuff, and all is cool. So I think it works even when you just drag this out, and then you also have add reroute node. So if you know, I want to route this through here and then there and then up, you can just drag this to wherever you want, let go, also scroll down all to the bottom, add reroute node, and there you got it. And from there, the very same thing, but let's try to keep this straight, like so. And then all the way down, add reroute node, and then to wherever you want. Okay, let's throw them away, and let's see that we actually get stuff. Let's see that we prevent the door from just rotating all over the place. Let's see that we get the door to stop at like 90 degrees. I think 90 degrees for now is perfectly cool. So the door, it starts closed, and then it slowly starts to open. And everything is fine. And when it hits 90 degrees, it just stays there. It's open and everything's cool. So how do we do that? What we're currently doing is we are only calling one function. We are only calling the set actor rotation, which basically does exactly what it promises you. It sets the rotation of your current actor. Again, the actor is the whole thing. The whole construct, everything, this code, and this is more special code, and the viewport, which contains all the static meshes. that your actor is represented by in the scene. So we can actually see the door as a door. So if I click on this, this is my actor. And as almost everything that is somewhere in your scene, this has a transform. And part of the transform is the rotation. So I can set this to 45 degrees. And you see the door swings halfway open. If I set this to 90 degrees, which is where we want to stop the opening animation, it's there. And I can also set this to 13.37 degrees or whatever I want. For now, I'll just be setting this back to 0. So what we're doing here is we're calling this one single function to modify the current rotation of our actor, so of our door. And all these are not functions that are called. You can determine what's a function, what's a method that's actually being called with these white execution lines. Because execution has to start somewhere, like in your normal, in your classic code. Execution starts on the top and then it just goes down to the bottom, maybe with branches or whatever you programmed in there. But it's kind of similar here. It has to start somewhere. It has to have a top where it starts, and this top in this case is our event tick. This is something special. This is something the engine calls every frame, at least by default. You can't change this. You can't change how often or if it's called at all. By default, it's called for every actor on every frame. And what it gives us is the delta seconds. We talked about this last time. So if you want to know what the delta seconds are and why we're feeding them in and why we're multiplying our rotation value by the delta time, then check back last week's session. And it gives us an execution pin, an exit execution. So this can trigger any function call, because these execution lines, wherever they go, wherever they end up, this is going to be called next. So if I pin this in here, this one will immediately call that one. And if I have any function, any other function here, let's just for example's sake, let's take the print string, and I want this to be called after this. So everything that has an input for an execution line also has an exit for an execution line. So I just drag the exit, the execution exit here to the execution input there, and that's basically it. Now, when this is done, when this is finished, execution will continue down the white line, and this is the next thing that's gonna be called. If I want it the other way around, let's just break those lines here. And if I want to have it the other way around, first I want this one to be called, and then I want to be this one called. I just plug this one at first into this one, and then into this one. Okay, but that's not what we want. We just put it in there, delete this, so everything's like we want again. So, and this function, it needs some things to know. It needs to know what is the new rotation of the actor you wanted to set to. So that's why it has this new rotation input. And if I break this line quickly, you can see there's 3 inputs. There's the X, Y, and Z axis that define the actual rotation of our actor. So the problem is if I just type something hard-coded in here like 45, let's compile, save, and run this. The door will just sit there, even though, okay, wait, need to lock my mouse here. Even though we set, oops, now I moved something I didn't want to move, but I think I didn't break anything. Yeah, even though we have our actor with no rotations is all on 0 and the door's closed and I hit the play button, it's still halfway open because that's the rotation we just just set in our code, but that's it. It's just sitting there at this fixed rotation, because the 45 I entered there, it doesn't change. This value, it's like war. It never changes. So what I can do is, because this also has such a neat little input plug, I can plug another value in that comes from somewhere, like another function, a variable, or whatever. Any value I have that fits the type, and this is type rotation, and any value of the type of rotation that I have, I can just plug in there. Luckily, I have a make rotator node here that creates a rotation value out of 3 plain float values. So we plug 3 float values in there, and it returns, it's kind of, rotator is kind of like a vector. You can understand this as a vector, a 3-dimensional vector that's just differently named to make absolutely clear this is not the direction you want to look at, this is a rotation. But it's basically a 3-dimensional vector, and we need to create this from our 3 float values. And since I now have this value here, this is my return value, and the types match, I can just plug this in there. And now this function, when it gets called, it gets the value from my vector, my rotator creation, plugged in. So whatever the value of this is, it gets passed to the function, and then it just uses this and sets the rotation to whatever that is. Now, we have to have those 3 float values we create our new rotation, our new vector from. And we basically get them from the current rotation. And again, these are not, and those are not functions that are called. Those are values that exist somewhere. This is like a property of your object. If you're familiar with classic coding, this is an object. This is a property of your object that just has those rotation values. It's actually, if you really create this, we use a little trick here, and unfortunately it doesn't work when I just copy paste this. So let me add another get actor rotator. Get actor bounds. Where is it? Get actor rotation. There it is. If we just newly add this node, you see it has this little, pinkish, gray, pinkish. There's a flower name. That's lavender. Yeah, there's this lavender colored output pin. And I could immediately plug this into our function, because this return value, this value is of the type rotation. So I could plug this in here. And if we try this out now, nothing should happen, because what I'm basically doing is I'm getting this property, I'm getting the value of this property, which is the current rotation, and I set this as the new rotation, which is the same, so nothing changes. But the important thing is that's not a function, that's just a value that exists somewhere. And the neat thing is, you don't have to take care. This is different to, well, not that different. If you're coding and it's just a property of your object, you can just access it and you don't really care where it's coming from. But here you don't even have to care less about where this value is coming from. You just know there's a value, get actor rotation, and you can use this. You can access this and then use it for other things. And what we did here to get those 3 little float values is just if you have a value, some of those values are data structures or things similar like this, consisting of other separate values. Like in this case, it's just, I mean, a float vector is just a collection of 3 float values. So for some of these values that actually consist of separate, different separate values, unrealistic, high, wait a second, I need to collect my chat bonus, yeah? Need to do that. Need to have my chat bonus. A wonderful evening, high. Perfect timing, we're just starting to dive into the really interesting stuff. So if you have values like this, that it consists of multiple different separate values, most often you can right click on it, and then you have split struct pin. And if you hit this, it replaces the one value that you get with the struct you get as return with the separate values. May you ask me something? Yeah, of course. Ask away. As long as it's not too personal. But basically, that's why we're here. You want to study programming in September and you're still in high school, but you have zero knowledge about programming languages. Is it possible for you to attend that university then? I can't answer you that because I don't know that university. That's a question you should actually ask to the university or to people who know the courses that they teach. Because both is possible. Sometimes you need to have some knowledge prior to actually starting the courses or the studies, and sometimes you don't. So since I have no idea, since I don't know your university or the courses you're about to take, I don't know. Sorry, I would love to be able to answer you that question, but you should better ask this directly at the university and ask them, hey, do I need to have prior knowledge, at least basic stuff about programming things? Or do we really start from scratch? Do we really start over? And then depending on what they tell you, decide what you're going to do. If you say, no, this is software development 101, we start from scratch, we teach you everything you need to know, then that's perfect. That's exactly what you want. Otherwise, depending on how much prior knowledge they require, maybe do some tutorials and try to get your feet wet on your own already. But yeah, that all depends on what they actually need, what they want from you when you start there. Sorry I couldn't tell you more, but well, it was worth a try. Definitely worth a try. And you're welcome. All right, so what we did is we split the struct up. Is Python HTML a good start? HTML definitely not, because HTML is not a programming language. HTML is it's a markup. HTML is simply some like Markdown. I mean, I know if you've seen some I don't know, readmes from GitHub or so, there's sort of Markdown, and HTML is markup. I have no idea why they call it that way. But Python is definitely something you could start with, because Python is used quite a lot. I personally do not use Python for personal reasons. I'm sorry. Python and I have completely different opinions on one single topic, and this is the reason why Python and we will not really get friends anytime soon. So yeah, long story short, HTML for learning programming, no, because HTML isn't programming. It's just defining how your text is supposed to look like. It's more like This might not be the best comparison, but HTML is more like using Paint, when programming is more like using Visual Studio or stuff. But yeah, Python definitely, if that's cool, if that works for you, if you like Python for whatever reason, then yes, because Python is quite widely used for a lot of things. So that would definitely be a good thing to start with to get your feet wet. Yes, absolutely. And no problem for the interruption. That's basically why we're here. That's the reason why this is taking part as a live stream and not just a pre-made YouTube video. Because we actually want you guys to ask questions. This is exactly the reason. Questions like this are exactly the reason why this is a live stream and not just the next YouTube video. Because in YouTube videos, you can't just say, hey, I got a question. But here, you can, and you should. You're welcome to. So, and what we did here, to answer that question, what the heck did we did we there see? As soon as Marsus enters the chat, I'm gone. I'm so nervous. Greetings to you. A very well, what is it? It shall be the evening for you, as it is for me, because we live in the same time zone or something. I don't know. Hi there. Yeah, we split this up. We got those neat little 3. It's after midday. Yeah, it's definitely after midday. And it's before couch time. It's before couch day. Midday, well, middle of the day. Couch day is a whole day of couching. That'll be the case in 2 days. Couch day will be in 2 days. Absolutely, all day long. Yeah, it's I don't know. Soon before couch time or something. Or at least I hope for the most of you, because it's getting late and every day needs to have an end eventually. So yeah, we split them up. We got those neat little 3 float values, and since we didn't want to change X and Y, those can stay perfectly as they are. We directly fed them into our rotation maker that I also can plug in there because now we know why and how. But we wanted to change the Z rotation. So the door actually swings open, and we did this by taking the current. So see current, the current rotation, we add something on top of that, and the result of this addition we feed into our rotation maker, feed this to Z rotator, and this is why our door starts swinging. Because each and every frame, our blueprint grabs the current rotation value of the door, adds a little bit to the Z value, and sets this as the new rotation, which results in a perfectly fine, well, I've said the word a few times now, I think you can guess it, right? Not movement, the other one. Rotation, exactly. So, that's that. Again, if you want to know what's up with the delta seconds and how that works and why that works, check back last week's session where we added that and tried to explain why delta seconds prevents you from making something like Fallout 76 or something. So what we now want is we want to stop it at the 90 degrees mark. So if you're familiar with classic coding already, you know there's a conditional phrase called an if. Because if something is the case, then we want to do something else. Or else, maybe, we want to do something else. Sounds confusing? Nah, isn't really. So, even in blueprints, we should have something like an if. Just that it's called a branch, which is totally right, because it found exactly that. If I typed if in here, it already highlighted me, and it even gave me this little, this is my little favorite star, because this is exactly what we're looking for. So yeah, we want to branch, because depending on if something is the case or not, we want to do something. And except for here, I told you that everything that has an execution input also has an execution output. Yeah, they definitely at least always have one, but sometimes you have more than one. There's like, I don't know, I think the for each loop or something that has like 3. No, it also only has 2 for a loop body. Well, maybe there's, I don't know, maybe there's some that have more, but in this case, we have 2 execution outputs. So this, of course, as we already know, this is the one to trigger this, so that this part, this node, this little rectangle is executed. And should the condition here, which is a Boolean value, and a Boolean value is like your classic light bulb. It's either on or off. There's no in between. It's not a dimmed light that can be half off. It's just a light. It's either on or off. And if the light is on, we call this true. And if the light is off, we call this false. So should this be true? See, and here we have the exact line, the exiting exact line. Say that 10 times in a row, really, really fast. For true and 1 for false. So depending on if this light bulb is on or off, either this one continues with the execution or that one. Not both. It's just one of them is triggered, but it's either this one or that one, depending on what the condition says. So we need a condition, and our condition is basically, well, is the rotation still below 90 degrees? So let's see if we have something, because I haven't done this in blueprints yet. So compare float. Yeah, we want to compare some float values. That's cool. So we need to, what do we do? This is the value we put in there, but we only want to execute. Okay, let's first just place our nodes wherever we feel like, and then see if we maybe can clean this up after this. So we only want to call this if the rotation is still below 90 degrees. So we cut the cord, we cut this execution line there, and we put our branch in here somewhere. Oh, and this is interesting. This already, I think we don't need the branch. Oh, this is interesting. We don't need the branch because the compare kind of already does it for us. And see, here's one with 3 execution outputs. So perfect coincidence. I would have liked to show you one with more than 2 execution outputs. And here we have it, because so we move this aside. We might actually be ending up deleting this. And I think we can just delete this right now. So this also has an execution input. So this is executed at some point when there's an execution line coming in here and triggering this, and we got an input and something to compare it with. So basically 2 values, and this thing then checks how these things are compared to each other. And if you have 2 numbers and you compare them with each other, Jesus Christ, my speech subroutines today, yeah, I don't know. They might be as glitchy as the frame rate with this capturing, but again, as long as the streaming PC holds up and does not lock up like last week, I'm happy. I'm perfectly fine. So if you have 2 numbers and you compare them with each other, there's 3 possible outcomes. Your second number is higher than your first one, it's lower than your first one, or it's exactly the same like your first one. What we want is, we want the lower one. So let's plug this in there. And this is, wait, does that work? Oh yeah, because sometimes you not only want it to be lower, you want it to be lower or equal. And then you want to do things. So what you can do is you can plug multiple execution exits into one execution input. But that works all the time. So I could also drag this one back into there. So while an execution exit also can not only go to one, I think they also can go to, just not to themselves. Okay, they can't go to themselves, but they can go to multiple ones as well, I think. I thought wrong. Okay. An execution output can only have one line that goes somewhere, because that one thing can only trigger one another thing. There's special nodes that actually allow you to trigger multiple things when one thing is true. So we have one input and several execution outputs, but they are basically called one after each other, but they are all called in case there's one thing you want to trigger multiple things with. And again, I have to snag my chat bonus there. So for now, because this looks a bit weird, we just break this, and you know what, we break them all, because that from there really isn't what we want. So we want, when it's lower, we want to call this, but when it's lower than what? When it's lower than our 90 degrees, because we want the door to swing open to 90 degrees, and once the rotation is higher, then we're done. We're not doing it. So there's our 90, and we need to have the other input, which is our new float value, our new rotational value. And let's see that we... Yeah, this will get... See, and this is where it starts getting messy, because we definitely will have the beams crossing. And for all of you who've seen Ghostbusters, you know, don't cross the beams. But in this case, I don't think we can avoid this. So let's put this, I don't know, somewhere like there. And then plug this in. So this is our initial execution. This triggers the first thing, which triggers our comparison. And thinking how to segue into this. Yeah, I don't think there's a good comparison, a good segue into this, but I could construct something with a car, but that doesn't right work. But well, what's on my mind is when we talk about the comparison, it might be a comparison Ford. Yeah. Now you know. Once you've heard it, you can never unhear it. Also, let's move this a bit up, because I like my lines, my wires neat and tidy. And see, all of a sudden this one's messed up again, but we can fix this, and we know how. Straighten the connections, see, and all of a sudden they're fine again. They're not. We need to straighten those as well. And that looks good. That looks fantastic. Just that when I move this closer, it messed up again. Yeah, this is because when it straightens them up, they don't align perfectly. Oops, what did I click there? Align right. Whatever, it worked. Because you can see if you move these nodes around, it snaps to a grid, similar to when we have the snapping feature enabled here and we move stuff around, then yeah, that snaps, and these snap as well on a grid. So when you use the align function, they might not be perfectly on the grid. They might be somewhere in between to have to force the line being neat and tidy. So if you start to move them and it snaps to the grid, or it's messed up again and you have to realign them. That is something you have to live with if you want to make your blueprints neat and tidy, which I absolutely suggest you should be doing, because we try to make our normal line-by-line written code to be neat and tidy and comprehensible and clean. So this looks even nicer when it's clean. You should maybe I'll dig out a blueprint of our current project. There's a few that look really nice. They actually work and they look nice. All them straight lines and everything. It's cool. I like it. So yeah, this basically might be it. I mean, we're getting the current rotation, we're adding something to it, and then we are checking, we're comparing this to 90, and if it's below 90, then we call the set actor rotation, and otherwise, well, we just don't. So let's compile and save this. And our door should now, when we go into play mode, it should swing open to 90 degrees and stop. So let's try this again, but look at it from the outside. And there's our door, swings open, and once it hits the 90-degree mark, it just stops there, sits there, and everything's cool. And well, we're kind of pretty happy because that's basically how our door behaves, right? And because it's so nice, let's look at this again. There it is, swings open, 90 degrees, and it stops. And we can fine tune this. We can set this to everything we want. We could set this to 45. Don't forget to compile and save. You don't have to save. It works when you just compile it because the engine knows about your compile blueprint. But I always do compile and save because once you save, you have it on your hard drive. You have it, well, saved. So should the engine crash, which might, and depending on what you do, will happen, especially if you start coding, especially if you start coding C++, it will crash, it will go down. But it's not that bad when you saved your precious work. So for me, it's always the biathlon. If I change something, compile, save, and then go back into the editor view and go into play mode and see. There's our door stopping at 45 degrees. Let's try to see. We could make it a bit slower. We could also reduce the speed, compile, save. So now we have, see, and this is a neat thing. Now we have values that we can start tweaking around. This is our speed. This is how fast the door moves. And this is how far the door actually opens and actually moves. So let's try this again and see. It's way slower. We had enough time to move outside and look at our door. And again, at 45 degrees, it then stops. So we'll take a short break. For all of those who need to refill their lubrication, I luckily still have some. Or need to visit some very special places in your house, apartment, office building, or wherever you currently are. So we'll take a little break of just a few minutes. And after the break, we'll be taking a look at how we can put this into an actor component to reuse this. Why would we want to reuse it? What even means reusing this? Well, that is something we'll take a look at in a minute or two, or maybe 3, or maybe even 3.5, or 2.7 or something. Yeah. Be right back. And of course, need to open the mic as well. Start to talking without the mic. Well, that doesn't quite work. So, and we're back. Welcome. Nice you're still there, for all of those who are still there. And those who left, well, anything I could say now you wouldn't hear anyways. So, that's it. Okay, now, we got this little bit of blueprint code that actually moves our door. Let's actually set this back to 90 degrees, but I think the speed of 10 is okay to demonstrating it, to actually be able to see it moving. So, what if we have multiple stories, and what if we want to have multiple moving doors here as well? Again, see this only as an example of your actual business logic. If you have an object, or if you have a door that actually properly behaves, like when you move close to it, it starts opening or something. See this only as a placeholder example for the amazing stuff you're actually doing in your actual projects. So if it's all the same door, it's pretty easy, because we have our actor, we have our blueprint door actor here. And if it's all the same door, this is very easy. We just drag our doors in here. We have lots and lots of doors. Not affiliated with the music band, of course. And if we now start this, all of those doors, of course, swing open to 90 degrees, because they are the same actor. Those are all instances of the very same, even though there's multiple doors now, those are just multiple instances of our one blueprint that we created. And this one blueprint has all the code it needs for our door to function. So let's try to get rid of them. But what if we have, I don't know, different doors? And just for the sake of argument, just for having some, so it actually makes sense, because if I start showing this with all the same actor, it might still not be totally clear what I'm talking about. So let's make another door, and let me see. I need to try out the dimensions again. But let's make a few more doors. So let's get this over here. Get over here. Oh, Mortal Kombat. Yeah. We can talk about Mortal Kombat. That's game dev related, because Mortal Kombat is a game and it was developed. So that's totally game development. So, stop my rambling, do actual stuff. I don't know, what was that? Was that 150? I'm not exactly sure. We're going to be finding out. I think that was 150. And this was 100. Maybe. We'll see. We'll see if that fits. And this is like third. No, wait. That's the door. That's not the thing we want to create the hole with. This can be our door. So let me. Yeah, that's looking good. That looks just like the proper dimensions. And you know what? To make this example even more exemplarish, let's create another one. And of course, I totally forget to properly texture them. I forgot to select a material before. So let's just do quickly. What do we want? This one down there, for some reason, it became metalish. I have no idea why. Something went wrong there. But that's exactly what I was talking about. I was talking about creating meshes from brushes, from geometry brushes, is not a desired way. It's not a proper way to make your meshes. It's just something for prototyping, blocking out or trying out stuff, and that's basically what we do. I think what would be look funny if we have a water door, but that's more for like when you build a Stargate, you know, just plop some in there, water texture, and you get your Stargate. I like these kind of textures. Let's use that one, because I really like that one. Let's put it on the other side as well. And let's just, let's just leave the other faces untextured. I don't care for now. This is just for demonstrating. We need another door, so we need another texture. Let's take this nice wood texture. Let's make this a plywood door, because that pretty much looks like plywood. And we also, for, you know, I showed you last time how to combine. Come on, let's do it. Nah, let's just do it. Let's grab a sphere. I mean, it's not that hard, right? Let's grab a sphere. Whatever I'm moving there. Okay. It of course definitely needs to be smaller. What would be a nice size? Would that be a nice size, or would that be a more nice? I think let's say 15, something in the middle. So let's bring this in here. So we have our doorknob, because doors need to have knobs. And I hope it doesn't. I hope it. This is too big. Let's make this 10, not 120, just 10. Still big, huh? 5? Yeah, 5 looks okay. So, and I hope this doesn't mess up my textures like the last time when I create a mesh out of this. Or if it does, you know what? Let me keep a backup copy. So, oh, wait, no. This was, I didn't want to move this. I wanted to copy this. So, in case it actually does mess up our textures, we can try this again and see to not mess them up. So, then a copy of this. If you think this quick copying, dragging out a copy is pure magic, then you're right. It is. And if you want to know more about this magic, if you want to know what the magic is and how it works, check out, actually not sure if it was last week or the week before. I think it was also the week before, where we talked about these little editor shorthands. And yeah, this is looking cool. So let's select this one, and this one. And let's try to create a static mesh. Is it already messed up? No, it's not messed up yet. Nice. So we call this SM door 2, because that's our static mesh for our second door. Create. Okay, I have no idea what I messed up when creating this, because this looks like it worked. Oh. But those are not properly aligned. See? Good that I noticed before. We need to move this a bit more inwards. And of course have to do the same with that one so they neatly align. So select the other two. I hope they are all three selected now. Looks like it. Create another static mesh, which is our door 3. Great. So now we have in total 3 static meshes with doors. We have our first door, we have our door 2, and we have our door 3. So we can delete all those things. And I can, of course, also delete this brush because we don't need them anymore. We now got them as reusable static meshes. So I can pull as many of these doors into my level as I want. But we want them to be actors. We want them to be to do something. So with the third door, we're actually going to be trying something, because let me see if I just drag this. No, okay. Nah, no need to try, because I can't put any more components on this. All right, yeah, this already answers that question. So we need more blueprints. We need another actor. And this is our blueprint for door 2. And we need yet another actor that is our blueprint for door 3. And this already shows you why we want to create components for these things. So first off, let me go into this actor, add a static mesh, which, whoa, this is small. And this is our static mesh door 2. And let me see that I get this properly aligned to the origin of our actor, because that defines where and how the door is swinging. Maybe we want a door that swings in the middle. We could do this. Yeah, let's do this. Let's do this with door 3. So I'm going to be aligning this properly to, at least I hope. Oh yeah, it's hidden inside the door. That's looking good, actually. So can I move this down? Pop. Oh, okay, that's too much. So let's change the snapping to 5 and let's move this just a little bit up and also a little bit more to the side. So you can see now this white ball here. This white ball symbolizes the origin, the absolute center of our actor. So that's the middle. And this is also the pivot point. This is if the actor is going to be moved. We talked about this last week a bit. If the actor's been moved or rotated or anything done to it, it's always happening around this center point. So this is why I have the door, this edge of the door aligned with the origin, with the pivot point, because if we now rotate the door and swing it open, it rotates around this point, which aligns with this edge, so the door properly swings open around this edge. We're going to do this a bit different for our third door. So this works fine for our second door. So let's open our door 3 blueprint. And again, add a static mesh here, which is our door number 3. That one. So, and I'm going to be aligning this like in the middle. Oh, Cyber Wolf is following. Hey, I know you. And I need to answer your Discord DM. I will be doing this right after the stream. That definitely deserves an answer. So, you see, I now aligned the door. Let me see that I can move this. Yeah, this aligns. This is lined up there. You can see the difference. Like this one, the center, the origin, the pivot point is in the middle of the door. And here it's on the left edge or the right, depending on which side. It's on the edge. It's on the edge. And on this side, on the edge of the door, is the pivot point, the origin, the center of our actor here. And here it's in the middle. And quite soon we will see what the difference is. So compile and save, compile and save. And this is the old one. This is already saved. So now we got our blueprints for door 2. We can slap door 2 into here. And let's see that it's properly in there. Oh yeah, that already looks pretty cool. Look at that. Perfect hit. So, and let's put our door 3 into there. Yep, also neatly aligned. So, and see, if I move this door, it behaves exactly. Let's go up here, and if I change the rotation to like 45 degrees, you see the door swings open just like our other door did, because you can also see in edit mode, you see the pivot points, the origins of the actors as well. They are not shown when you go into game mode. So if you go into game mode, you can see It's all clean. You don't see these little balls floating around there. That's just innate for you, for the developer in edit mode, so you know where's the center, where's the origin, the pivot point of my actor. And here it's right on this corner of the door. So, and here it's in the middle. So see what happens. Whoa, what was that? Control Z. See what happens when I say I want to rotate this by 45 degrees. It swings open like a revolving door. And actually, this would be actually okay if this keeps swinging and swinging. So this would actually be okay, because this would be a proper revolving door, because it rotates around the middle and not around the corner. So this is the difference. This is why you need to see that you align your meshes that you put into your actors properly with the origin. So the result you get is actually the result you want. And if it behaves weird when rotating or stuff, then this might be the reason. So now let's set this back to 0. And now we want these doors to move as well. I mean, we have 3 different doors now, which is pretty neat. But if I move out here, only one of them moves. So now one thing we could do is, because the reason why only this one moves is because those are not only different meshes, those are also separate actors. They are completely own entities. They have nothing to do with this door. They don't have to be doors. They could be enemies or spaceships or whatever. This is just an example. In this case, it's doors. And this actor has the code on it that makes it move. And these actors don't. So one thing we could do is, I could just select this, Control C, go into the other actors, Control V, and have the code there. Neat. Fine. Bad idea. Bad idea. Copy-paste code is always a bad idea. Copy-paste code, having large blocks of code, or even small blocks of code, that are exactly the same. Not only the result, they do the same, but the actual code is the very same. We don't do this in classic coding already. It's something you really want to avoid, because the problem is, it works for now. If I copy paste this onto the other actors, it's perfectly fine. But remember, we changed this today. At first it was rotating, and then we added something so it stops at 90 degrees. So if you have copy pasted this to all the other doors, to all the other actors as well, and you want, I need to have them stop at a certain angle, you would need to do this change to all your pasted code on all your actors, which is not only error prone, but also a lot of work. And we don't want both. We don't want errors or mistakes, and we don't want too much work. So we don't want to copy paste this for many, many reasons. And one way to still get the same code running on all of those actors is to make an actor component out of it. So that's what we're going to do. We create a new blueprint class, just like we did a couple of times for our doors now already. But this time, instead of actor, we select an actor component, because an actor component is basically a collection of code that by itself is not executed. It exists, but it's not really executed. But you can then attach your component. You can attach your actor. This is why this is an actor component. You can attach your component onto an actor, just like we did with the static mesh. Remember, when we added another mesh here, we said add component, and we looked for a static mesh, which is just another component that does special things. And this is something we can do as well. So we create a new blueprint and we say actor component, and we call this our door let me try to type door movement component. And let's open this up. Well, it's quite empty. Now we can copy paste this in here. Yeah, it messed up the lines a bit, but well, for now that's okay. Let me see that we get a better view that everything fits. So this is the event tick, and there's our delta seconds. Let's try. I mean, this is an actor component. This is code that's going to be reused. So let's actually try to make this neat and tidy. Straighten. Add a redirection here. Tidy that one up, if it lets me. So this looks neat, isn't it? So this code now is part of this actor component. We still have it in this actor. Oops. Hello? I want to hit this key. Not anymore. So that's what I want. That was actually the punchline I was aiming at. We have this code in this actor. Not anymore. Zebi! Hi! A wonderful evening to you. Nice for you to stop by. We're just doing super interesting stuff. We're building actor components. So this code now is not part of any actor. It's just in the component, kind of like a library. It exists. It's just there. But it still does the very same thing, but we deleted the actual code from our door. So let's compile and save this. Let's also compile. Oh, we got errors. The blueprint itself is not an. Oh, therefore target must have a connection. Okay. Get actor rotation and set actor rotation. Of course, they want an actor as inputs, and they need to know what actor to act on. And so far, we didn't need to put anything in there because the default is self. And self, well, the name's the deal, is the actor itself. Now, we're not inside an actor anymore. This is an actor component, so it properly tells us target must have a connection. So let's see if we find something. Get actor array, get actors, get actor array, get actor or class. Maybe we got a get owner. And this should, this should return. Let's see if that works. This should work because get owner is the value of the actor that owns this component. And that's exactly what we want, because we don't want to change the rotation of the component because the component doesn't have a rotation. It's just some code that's somewhere. We want to change the rotation this component is attached to. And the other way around would be the owner, the actor that owns this component. And we can plug this in here. And depending on how neat and tidy we want this, we could either drag another line to there, or we could copy paste it to there. But I think we might get away with a neat redirection node, maybe. That's not really nice. Nah, that's not cool. That's, you know what? We copy paste this value. We just use this here as well. I need to squeeze that in there. Yeah, see, this is. You could spend so much time actually making this really neat, because what we also could do is we could move that stuff a bit further down there. So the get owner and the green wire they don't intersect. Oh, you nearly understand something. Okay, that's cool. So let's, you know what? Let's trick a bit. Let's add some reroute nodes here, and then we can squeeze this in. First off, we need to align those again, and then we can squeeze this in, connect this there, and whoops, see that now I want to move it. I like to move it. That's all I want to do. Move it. See, that looks nice. Doesn't that look nice? See, it isn't that hard. If you just try a bit, you can really get your blueprints neat and tidy. And that looks good. So that should compile now. And it does. Let's hope it actually yields us the correct value. It yields us what we want, but there's only one way to find out, right? So compile and save. So if we go now into our scene, and we're going to play mode and run everything, of course, nothing moves. Not even our first door opens again, because, yeah, we removed the code. Remember, I deleted the code from this door. So how do we get this to run on our doors now? Well, pretty easy. We go into our actor, and just as we did with our static mesh, we can say add component, and do we find it? Yeah, up here. I hope you can see this. I'm not sure how well you can see this in the stream. Let me try to get this magnified a bit. But there it is. There's our door movement component. This is the one we just made. This is the blueprint we just created. The BP door movement component, and we just add this, and that's it. That's all we're gonna do, and we do this to the other doors as well, and we say door movement component, and we go to our third door movement component, compile and save, compile and save, compile and save. And all we did was just say add component and, well, add our door movement component that now holds our code. That's all we did for the doors. And if I didn't have a huge thinking problem or a mistake in there, see, all our doors are now moving. None of these doors actually have the code they need in them. None of these actors really contains the code that's needed for the doors to move. It's just a component. We put this code in a component so we can use this as many times wherever we want. In theory, I could even, this might look a bit silly, but I mean, why not having a good laugh? This is only a mesh. Let me create another blueprint, an actor, and let's call this floor, and add a static mesh there, which is our room. Let me see if I find it. I forgot how I named it. What was the name? Do you know? What was the name of our room static mesh? Our first room. Okay, yeah, that's easy. So, room. There it is. Static mesh, our first room. Let's see that we align this at least a bit. Doesn't have to be super precise. It's just to show something. But still, let me see if I can get this aligned on the floor a bit. Where's my pivot there? And up it goes. Oh yeah, that looks good. And then somewhat in the middle. Is that the middle? Not sure. Is that the middle yet? Is that more middle-ish? Yeah, this is for demonstration's sake. This is centered enough. So Let's save this one, go back into our scene, and here on top of all our buildings we have built so far, these are just static meshes, right? These are just the static meshes we stacked on top because they are decoration in the level. They don't do anything because if they want to do something, they need to be an actor. Technically, static meshes are also actors in the scene, but they're a bit special. Because they are static mesh actors. So they are actors, but with some code that already does put some behaviors on them. So we want something that we can completely control. So now we made our blueprint of our floor. That just has our mesh in there, and for some reason, maybe it's perspective. Yeah, it's just perspective. I was about to say the scale doesn't fit, but well, that was just. So that's not perfectly aligned. Oh, I think it should be okay for just demonstrating it, shouldn't it? Yeah, this is okay. See, and now we got another floor in our skyscraper here, and of course nothing happens because all we've done is we've created an actor that has this static mesh as static mesh to visualize it. But remember, we made this component, and you can put any component on any actor. So I could also go onto my floor actor and add our movement component onto my floor actor. Compile and save. I haven't put any actual code in here. I've just attached our component to our floor actor, and this should look quite funny if I now move outside and the mouse isn't properly trapped. Let's try this again. So if I now move outside, you can see even the upper floor is moving because we attached the component that rotates to 90 degrees also on this. And this is why you want to use components. This is how you use components. If you have some functionality that you want to apply to different actors, you put it into a component, and then you put the component onto your actor. And if you have multiple things you want to do, you have multiple components. Like if you're making a space shooter game, you have your spaceship. So you want the spaceship to be movable so that the player can control it. Then you want it to be able to shoot, or you want it to be able to explode or do damage or take damage. And you can put all these separate things into components, and then you just create your actor, your spaceship actor, and you put the movement component on there, you put the shooting component on there, you put another component on there, and then you create your enemy spaceship. And you basically just slam the same components onto this spaceship. Okay, given the components can handle, can determine if they are player controlled or AI controlled or whatever. But you get the idea. So components are functionality that you can reuse, that you can apply to any other actor where you need it, no matter how silly. One last thing we're gonna do today is, because now they all rotate with the same speed and they all rotate to 90 degrees. If we have such a versatile component that we can apply to many different actors, maybe with some of them we don't want them to be like all the same. We don't want them all to rotate 90 degrees or all with the same speed. Like if you have a component for your enemy spaceships, the movement component, some spaceships are bigger and slower, some are smaller and faster. So you want to change those values, and you can do this. So let's go back into a component and let's create a variable. And those of you who know a bit about coding already, classic style, or maybe even with blueprints, you know, oh, variables are nice. A variable is basically a thing that contains a value. It's like a drawer I like always like this analogy. It's like a drawer in your cabinet or closet. That's your variable because that holds a value, and then you can open the drawer and there's a sheet of paper in there, and the sheet of paper says 42. So the value that's in this drawer, so the value of your variable in this case, is 42. So let's make one variable that we call movement speed, and let's create another one that we call move until. Those names, I don't know, could be better, but I think they kind of depict what they are. Also the type, by default, it set it to be a Boolean, so that was the light bulb switch. It's either on or off. So let's say this is a float, because we know we're going to be dealing with float values there. So also let's set the type here to float. And I think we don't need to do anything special to have them available from the outside because they're not set private, so they should be public. You can put a tooltip in there or anything blueprint read, or the variable can be set by blueprint nodes, or if it's read only. No, it's not read only. So it ends up whether this very public available in the instance of blueprints. Yeah, let's do this. Let's do this. So now we have two variables here, movement speed and move until. And what we can do is we can now just, this is where we set the speed, right? This is where we set our speed that we multiply with the delta seconds. We add this to the current and all the yada, 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 yada. So what we can do is we can just drag our movement speed onto our stage, let go. And now we get two options, get movement speed or set movement speed. Set movement speed if we want to change the value of this variable to whatever we just have here. Oh, we don't want to do that. We actually want to know the value that's currently in this variable. So we say get movement speed. And instead of our hard-coded 10 here, we just plug this in there. So now we don't have our hard-coded 10 that is our movement speed, but we get it from the variable. The same is for the compare with. This is our move until, and we want to get this. And yeah, there would be a way to avoid the crossing. I could move this a bit down the line, and let's just cross the lines, or oh well, maybe not. Let's see if this works. Yeah, works. Let's add a redirection node here, and let's move this there, because you really should try to avoid crossing lines, not only for beautification, not only to make it look nice, but also to keep it understandable. Because if you end up with a blueprint with so many lines and they all go crisscross and total chaos, timey-wimey, wibbly-wobbly, it's kind of hard to understand what's happening there, what you're gonna do. So you really should try to avoid crossing lines, not only because it looks nice, but also it helps you to keep an overview of what's actually happening. Because you don't have a whole bunch of lines that go all crisscross. You know, okay, this goes to there and this goes to there, and that then calls down there. Clean code is code you can understand even a month later. Because usually you write code, a month later you sit there, what the hell was I thinking when I wrote this? And this is exactly the thing you want to avoid. And keeping stuff clean, your classic code, you write line by line, as well as blueprints. It's the very same. The cleaner it is, the more you know what's actually happening when you look at your own code a week later, a month later, a year later, or a decade later, depending on how long your code's running. So now we got these neat little variables that we are using instead of our hard-coded values. So let's compile and save, and let's go back into our actors. And here, if I did everything right and I didn't forget anything, if I now select our door movement component here, oh yeah, there it is. Look at that. I can set the movement speed in our move until. These are the two variables we just created. We created a variable called movement speed and we called one move until. And now I can set, oops, that was the wrong button. And now I can set these individually for every actor. So let's actually switch to the viewport so we know which actor this is. So I select my door movement component, and for the variables we just created, I can say, okay, movement speed, this moves at 10, and this moves till 90 degrees. And the second door, it moves only with the speed of 5, but it also only moves till 45 degrees. And our third door, because this is such a nice revolving door, this moves at speed 20. But I don't know. I just a ridiculously high number because I don't want it to stop. I want it to keep spinning. So I just put a ridiculously high number in there. So that should keep it spinning for a while. And then we go to our floor, because our floor has our component as well. And that's like, I don't know, movement speed 15. And that does one full turn. That does 360 degrees. So let's make this safe. Let's make this 359 or something. I hope this works. Because Unreal tends to only do 180 degrees, and once you go more, it's minus 179. So I'm not perfectly sure if that works. But we'll see. So, compile and save. The worst thing that could happen now is that our floor keeps rotating, but I think it might actually stop. So compile and save. This is our component. Here's another door. Compile and save. Another door. Compile and save. Another door. And you guessed it by now, I think. Compile and save. So now let's jump into play mode. Let's run out and let's see what happens. And you can see everything's moving at different speeds. And the first door stops at 90 degrees. The second door stops at 45 degrees. The third door doesn't stop at all, and the upper floor should stop after one full rotation. And it doesn't. Okay. So it keeps spinning. Well, looks nice. So yeah, let's have this again. Let's run this and look, see. The middle door, the second door, it opens way more slowly than our lower door. They stop at the same time, of course, because our upper door moves half as fast, but also because I set it to 45 degrees, only half the distance. So, yeah, incidentally, the time when they stop is the same. And our revolving door, that's actually a proper revolving door because the origin is in the middle. It just keeps rotating and rotating and rotating. And you're having a horrible frame rate again. Bear with me. My setup today, it quite doesn't like me. But, well, we didn't do that much high frame rate stuff anyways. So yeah, that's it. This is, if you do Blueprint, this is what components are, actor components, how you use them, why you want to use them. And yeah, all of those questions. And that's basically it. Daddler, hi! My engine does not need to be real. It just can be unreal, unplayable frame rate. Yeah, it only looks like that for you. For me, it's perfectly smooth. I get all the frames I could ever wish for. But the capturing, the capturing doesn't work today. There is... I don't exactly know what's wrong with that. The alternative would have been to restart the streaming PC and everything, but that would have taken the stream offline for like 5 to 10 minutes, and I just didn't want to do that. So, since we didn't have to deal with high frame rate stuff anyways, I thought, okay, that's okay. That works. So, one last time, just because it's so nice, there's our 3 doors opening at different speeds, because that's what we said. Instead of, and that's also something you should do, instead of having hard-coded values, you always should have them settable. If you want to know more about that, on the last session of when we did the C++ stuff, we talked about a bit about best practices and how best to do things and why and everything. So yeah, if you're interested in that, you might just look at that. Yeah, that also concludes our beginner's tour for Unreal Engine, for people who've never started with Unreal Engine, who've never done anything with it. We started with a clean install, started the editor for very first time, changed the layout a bit, so it got a bit more usable, but well, that depends on, some people actually do work with the default layout, and that's perfectly fine. Like Zemi, yeah. So if you want to get started with Unreal Engine, check back the previous 2 sessions. Because as said, we started with absolutely nothing, started the editor for the very first time, took a look at how to change the layout so it fits your flow, your needs, so it's perfectly customized for you, how to navigate the editor, how to create our first geometry, how to make the geometry into proper static meshes, and then eventually we created actors and we added a bit of blueprint code to it, and now we also took a final look at components. So this should be all you need to get started, to get your feet wet, to get your very first things at all onto the screen. If you have any questions in the future, if you're stuck, if you followed this and you eventually hit a roadblock and say, okay, wow, what to do now? Feel free to ask. You can use the hashtag AskDevComTutorials on Twitter. You can tweet directly at me. The Twitter handle, I think it should be readable down there. Tweet directly at me, or if I get my mouse back and I remember the proper command, I think it was social. Yeah, there it is. If you haven't already joined the devcom Discord, and we got a special section for devcom tutorials and all other topics, many other topics as well. So find a channel that fits your question the best, or just drop it into the devcom tutorials channel. Drop your question, and I will see that we get them all answered, either just on the Discord, or maybe if it fits, we also can do this right here live, maybe while you're with us, and can ask follow-up questions or anything else that might not be totally clear. So, yeah, this is everything you need to get started, to get your first things moving on screen, and then from there on move forward. If you say, yeah, blueprints are nice, but I want to do C++ because I'm a hardcore guy, I like classic old school coding, then watch the 10 sessions we did last year where we exclusively focused on coding C++ in Unreal Engine. And starting next week, we will take a look at how these things are done in Unity, because there's another engine. There's not only Unreal, there's also Unity. And by popular request, we'll be taking a look at that. So this concludes actually our looking at Unreal at all for now. If you want more Unreal, just let us know via all the known channels. And yeah, starting next week, we will be starting to take a look first steps in Unity, how to get your first game object and how to get it movable. Pretty much the very same stuff we just did here, but how to do it in Unreal. And Well, it's basically the same. Most of the things just have different names, but that's it. So, yeah. With that, have a wonderful evening. See you next week. And, yeah, be good, be healthy, and see you around. Bye. Take care.